Have you ever looked up at the night sky and wondered how it all began? The universe, with its countless stars and galaxies, holds a captivating story of its birth and evolution. It's a story that begins with an event of unimaginable power and continues to unfold even today. This is the grand cosmic story, a journey that takes us from the very beginning of time to the emergence of life on our own planet. Our understanding of the universe's origins comes from scientific observations and theories painstakingly pieced together over centuries. It's a testament to human curiosity and our quest to understand our place in the vast cosmos. In this essay, we will embark on a journey through time and space, exploring the key events that led to the formation of our world and the emergence of life. Get ready to have your mind blown as we delve into the fascinating realm of cosmology and astrophysics. From the Big Bang to the formation of stars and galaxies, from the birth of our solar system to the emergence of life on Earth, we will uncover the wonders of the universe and our place within it. So, fasten your seatbelts and prepare for an awe-inspiring adventure through the cosmos. Imagine a time when the universe, as we know it, was confined to a point smaller than an atom. This incredibly dense and hot point contained all the matter and energy that would eventually make up everything we see around us. Then, approximately 13.8 billion years ago, something extraordinary happened. This tiny point began to expand rapidly in an event we now call the Big Bang. The Big Bang wasn't an explosion in the traditional sense, like a firework going off in the night sky. Instead, it was the rapid expansion of space itself, carrying all the matter and energy along with it. As the universe expanded, it cooled, allowing for the formation of the first particles and the fundamental forces that govern the cosmos. The evidence for the Big Bang comes from various observations, including the redshift of distant galaxies, which indicates that they are moving away from us. Another crucial piece of evidence is the cosmic microwave background radiation, a faint afterglow of the Big Bang that permeates all of space. These observations support the theory that the universe originated from a single, incredibly hot and dense state, and has been expanding and cooling ever since. In the first fraction of a second after the Big Bang, the universe was an unimaginably hot and dense soup of energy. As the universe expanded and cooled, this energy began to condense into particles, the building blocks of matter. These particles weren't the familiar protons, neutrons, and electrons we know today. Instead, they were more exotic particles like quarks, leptons, and bosons. These early particles were incredibly short-lived and interacted with each other at incredible speeds, constantly colliding, annihilating, and creating new particles. It was a chaotic and energetic dance of creation and destruction. However, as the universe continued to cool, a remarkable transition occurred. The fundamental forces of nature, such as gravity, electromagnetism, and the strong and weak nuclear forces, began to separate and take on their distinct characteristics. This separation of forces allowed for the formation of more stable particles, paving the way for the creation of the first atoms. Section 4. The first elements, building blocks of the universe. As the universe continued to cool, a crucial event occurred around 380,000 years after the Big Bang. The temperature dropped enough for protons and neutrons to combine and form the first atomic nuclei, primarily hydrogen and helium. These nuclei, with their positive electric charge, attracted negatively charged electrons, eventually forming the first atoms. This era, known as recombination, marked a significant turning point in the early universe. Before recombination, the universe was opaque, filled with a dense fog of free electrons that scattered light. However, with the formation of neutral atoms, the fog cleared, and the universe became transparent to light. The formation of these first atoms, primarily hydrogen and helium, marked the beginning of the universe's chemical evolution. These elements would later serve as the raw materials for the formation of stars, galaxies, and eventually, all the other elements in the periodic table, including the ones that make up our bodies and the world around us. Section 5. Gravity's Dance, the birth of stars and galaxies. After the formation of the first atoms, the universe entered a period known as the Cosmic Dark Ages. This era was characterized by the absence of stars and galaxies, with only vast clouds of hydrogen and helium gas drifting through space. However, gravity, the weakest of the fundamental forces, began to play a crucial role in shaping the universe's structure. Over millions of years, Gravity pulled together clumps of gas and dust within these vast clouds. As these clumps grew larger and denser, their gravitational pull intensified, pulling in even more matter. Eventually, the pressure and temperature at the center of these collapsing clouds became so intense that nuclear fusion ignited, marking the birth of the first stars. These early stars were massive and short-lived, burning through their nuclear fuel quickly and ending their lives in spectacular supernova explosions. These explosions not only scattered heavy elements forged in the star's cores throughout space, but also created shock waves that triggered the formation of even more stars. Gravity continued to draw these stars together, forming vast collections of billions of stars bound together by their mutual gravitational attraction. Galaxies.